MMK is the largest enterprise of the Russian steel sector and a fully integrated plant comprising all the stages of steelmaking, from processing of iron ore materials to downstream processing of rolled steel. Production starts with the mining and supply of iron ore and ore concentrates, followed by their further processing into ore sinter and coke production. Then comes the smelting of pig iron in blast furnaces. The next stage of production consists of smelting steel in BOF converters and electric arc furnaces. Steel slabs and billets from continuous casters go to the rolling division, where they are rolled into flat or long products of different shapes and sizes. Below, we describe in more detail each of the production stages. Sintering is a way of preparation of main raw materials for smelting pig iron in the blast furnace. Sinter comprises iron ore concentrates, iron-containing wastes, and fluxes or limestone, with coke used as fuel. The sinter division includes 3 sinter plants. Their aggregate capacity is about 10.5 million tons of sinter per year. Coke and Chemical Byproducts Division. This production cycle is based on coking coal. It is heated in special furnaces called coke oven batteries, producing coke, the main fuel for blast furnaces. The Coke and Chemical Byproducts Division comprises a coal preparation plant, 3 coke production plants, 2 coke gas recovery plants, a coking products processing plant, and several maintenance units. The coal preparation plant receives, stores, and prepares coal for coking, and supplies coal burden to the coking oven batteries. Coke is produced in 9 coking batteries. At present, the maximum level of production is 6 million TPY, of which 92% is used in blast furnaces and 8% is supplied to non-ferrous metallurgy and chemical plants. The blast furnace process is the process of smelting pig iron. To start the process, sinter, pellets and coke are supplied to the blast furnaces, of which there are 8 at MMK. The process is based on burning coke in the so-called tuyers by means of supplying air heated up to 1150 degrees Celsius. Blast. When coke burns, hot CO gas and hydrogen are formed, generating a reducing atmosphere inside the furnace. Gas participates in the reaction of oxides reduction and heats them. Gaseous reaction products are then transported along special gas ducts to the gas treatment unit, following which they are routed into the steel mill's blast furnace gas network for further use as a source of heat. In the process of blasting, air is enriched with oxygen with natural gas added. This allows to intensify the process in the blast furnace and bring down the consumption of coke. The thermal state of the blast furnaces must always be kept stable. Hot metal is tapped from the furnace on average 15 times a day. It is poured into the so-called torpedo cars and sent to the BOF and EAF plant steel smelting plants. In the meantime, slag is poured into slag cars, which are sent to slag processing units. The total capacity of MMK's blast furnaces is about 10 million TPY of hot metal. All steel grades at MMK are produced in BOF, basic oxygen furnace converters, electric arc furnaces, and 1 twin-bath steelmaking unit. The BOF plant comprises 3 370-ton converters, with a total capacity of 10 million tons of liquid steel per year. Hot metal from the blast furnaces is transported to the BOF plant in torpedo cars. Then it is poured into charging ladles, and from there into the converter. Scrap is added to the hot metal at this stage. Then oxygen is blown into the converter, oxidizing the carbon and silicon contained in the hot metal. During the smelting process, impurities containing sulfur and phosphorus are removed from the charge. The end product of the process is unrefined steel, ready for subsequent treatment in steel refining or secondary treatment units. A ladle car with steel is brought to the secondary treatment units where steel is blown with argon and a predefined amount of aluminium is added to it. After obtaining the required chemical composition and temperature, the steel ladle goes to one of the 4 continuous casting machines. There, steel is cast into slabs which have a rectangular section and are used as input material in hot rolling mills. The EAF plant comprises 3 steel smelting units, 2 electric arc furnaces and a twin bath steel smelting unit. All the steel smelting furnaces in the EAF plant use hot metal, steel scrap and ferroalloys as the main charge, and certain auxiliary materials such as lime and carbon-containing materials. An electric arc, natural gas, carbon-containing materials and oxygen are used to heat up and melt the charge. From these smelting units, steel is tapped into a pouring ladle. Then steel is conditioned to the required chemical composition for a relevant steel grade in secondary treatment units, with the steel temperature at the end of treatment being equal to that specified in the order and in line with the specific casting conditions. Continuous casting is performed in 2 5-strand billet casters supplied by Wurst Alpine, Austria, and 1 2-strand slab caster supplied by Uralmash, Russia. The slag formed in the process of steel smelting is collected in slag pots and subjected to subsequent processing. Flat, hot and cold rolled products account for more than 64% of the total production and are made in 10 rolling shops of the company. Hot rolled flat products are primarily used for the manufacture of pipes, while high quality low carbon cold rolled products are used in the automotive sector and as substrate metal for coating. Let us take a look at the hot rolling process as used on the 2000mm hot strip mill of the number 10 rolling shop. Slabs heated up to the required temperature are transported from the heating furnace to the roughing mill via a scale breaker unit and an edger. In the mill, the slab goes through 6 consecutive stands and is uniformly rolled into a strip. The strip goes to the flying shears and, from there, onto the finishing mill consisting of 7 stands. The finished strip is wound into coils and transported either to the cold rolling mills or to customers. And now let's look at the cold rolling process as used in the number 5 rolling shop. First, the hot rolled strip is sent to the pickling section, where scale is removed in acid tanks. Without this treatment, it would be impossible to obtain high quality material. Then the cleaned coils come to the cold rolling mill. After cold rolling, cold rolled coils are annealed in special furnaces for recrystallization, which is another important form of treatment to assure high quality. After that, cold rolled coils either go to the finishing section for cutting and shipment to customers or to MMK's coating plant. Now let's take a look at the basic process for manufacturing long products as applied in one of the company's new section mills, the 450mm mill. Everything starts with continuously cast square billets supplied to the mill from the EAF plant. These billets are first charged into a walking beam heating furnace, where they are uniformly spaced along the length and across the width. After the furnace, they are cleaned of scale by a hydraulic descaler, that is, by water at high pressure. The rolling process is continuous, which means that the rolled material simultaneously passes through all the stands of the mill. The cleaned billet passes through the roughing stands and then the finishing stands, which shape the cross-section of the transfer bar. The mill is equipped with stands with horizontally and vertically positioned rolls, which prevent the bar from twisting. The bar exiting from the finishing stands is cut by automatic shears, and placed on the cooling bed. After cooling, the material goes to the straightening and cold cutting section. Straightened and cut bars are stacked into bundles, marked and then transferred by means of overhead cranes to the storage area. Other mills can produce bar or heavy gauge wire in large coils. On the 170 and 370 mm mills, the wire, after water and air cooling, is wound into coils, then pressed together to tighten the coils and strapped by means of a special coil strapping machine. Finished marked coils are transported with overhead cranes to the storage area. Coated strip production. MMK's coating plant produces hot dip galvanized strip, electrolytic tinplate and colour polymer coated strip. The hot dip galvanizing lines can produce a wide range of galvanized strip 0.25 to 2.50 mm thick and 700 to 1650 mm wide. Galvanized strip and sheets can be painted, cold formed and used for car bodies. The coating is applied by submerging the strip in a bath with melted zinc. This line allows to make a thorough cleaning of the steel substrate for obtaining a high quality strip with two kinds of coating, zinc and iron zinc coatings. The process is controlled automatically. The design capacity of two lines is 1 mtpy. The colour, polymer, coating lines are intended for manufacture of rolled products with various polymer coatings in compliance with international standards. Coatings are applied by roller machines and then dried in horizontal ovens. The second colour coating line, with a capacity of 200,000 tonnes, was brought on stream in July of this year. The total design capacity of the lines is 400,000 TPY. Metalware, metiz in Russian meaning metal articles, are products of the highest degree of processing. It is produced by MMK Metiz, which is part of the MMK group. For example, let's take a look at how high-strength bolts, a typical metalware item, are manufactured. The input material for the production of bolts is hot-rolled steel. To improve its plasticity, such steel is first annealed in roller-through type furnace. The next step is to pickle the steel in acid tanks to remove scale, with subsequent rinsing, phosphatizing and lime treatment. Then special drawing mills draw the material into bars of intermediate size. Another form of scale is formed in the process, which must be removed by annealing, followed again by rinsing, phosphatizing and lime treatment. Then comes another drawing on the drawing mill, this time to the bolt's net shape size, followed by press forming and threading of bolts. To achieve required mechanical properties, finished bolts are once again heat treated in special quenching units. Then they are tested for compliance with GOST standards and accepted for shipment by inspectors of the Quality Assurance Department.